Good morning, sixth grade. Happy Monday. Let's get started by going over the follow-up problem for last week. The school is building a playground. Determine the number of feet needed to put a fence around the playground. The school wants to lay padded tiles down for safety. Determine the area in square feet that needs to be covered by the tiles. So for the first one, which was perimeter, no one struggled with that, so I'm not going to go over it, but I'm just going to remind you that when it's perimeter, you add up the side lengths, include all of them to do it. For the area, you are usually multiplying the length times the width unless you have a triangle. In this case, since the figure is irregular, it might make sense to split it into two pieces. When I did it, though there are lots of ways you could have done it, I split it here along that line. And then I found the area of this rectangle and this rectangle. So if I do that going across, I have 1, 2, 3, 4, 5, 6. So this is 6. Going down, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 times 10 gives me an area of 60 feet squared. And then if I do this particular rectangle, I'm going across 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2, 3, 4. That would give me 32 feet squared. So if I add this up, 60 plus 32, I have 92 feet squared as the total area. Okay, let's look at our challenge for today. It's about a computer table. Mr. Lengthy is looking for a new computer table and found 2 he likes. All the measurements are in feet. Number 1, if Mr. Lengthy chooses the one with the greatest area, which one should he choose, and justify your reasoning? If Mr. Lengthy chooses the one with the greatest perimeter, which one should he choose? Justify your reasoning. I'm going to give you a moment and go ahead and write down things you notice and wonder about this particular problem. All right, here are some of my notices and wonders. I noticed the 2 tables are different. One is in the shape of an L and the other has 2 legs and a middle space. To calculate the area, I'm looking for the space inside or on the tables like the workspace. To calculate the perimeter, I am looking for the distance, it should say around the tables. Wonders. I wonder what table will have a larger area. I wonder what table will have a larger perimeter. Which table would be better if I have lots of stuff to put on it or need more workspace? So again, here is the problem. Now is your chance to solve it, to think about what you might need to do. Go ahead and pause here and solve the problem on paper. Here is the problem in case you need to look at it. All right, let's look at how I would solve the problem starting with area. Because it's an irregular shape, I might want to split it into shapes that I recognize or rectangles that I recognize. There's many ways you could split this. If this was a rectangle, you could split it here and have one large rectangle and a small one there. You could split it here. There's different ways to do it. For the purposes of the strategy I'm using, I'm going to split it along this line to make 2 rectangles. So I could look at the area of this rectangle. I see it's 1, 2, 3, and up 1, 2, 3, 4. Oops. 4. So I have 12 feet squared in this part. And then if I do this one, it's 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 3 is 27. So I have 27 feet squared. And then if I wanted to find the total area, I can add this up. 27 plus 12 gives you 39 feet squared. That's for table A. Now let's look at table B. Again, there's many places you could cut it off. I'm going to choose to cut it here, here, and make 3 rectangles. You can do it how you see fit. I have a width of 2 and a length of 1, 2, 3, 4, 5, 6, 7. So this is 14 feet squared. I have 1, 2 again. This is 1, 2, 3, 4, 5, 6, 7. Again, this is 14 feet squared. And then if I look at the middle, I have 1, 2, 3. By 1, 2, 3, this would be 9. Will it let me write? This will be 9 feet squared. So if I add up these 3 amounts, I have 14, 14, which is 28 feet squared, plus 9, which is 37 feet squared. So even though the second one kind of looks like it has more space because of the way it's shaped, it kind of has like 2 legs. Really, if you want to choose the one that has the greater area, you're choosing table A. Now, choose the one with the greatest perimeter. That's the distance around. To make this less confusing, I'm going to erase what I did because I don't want to mix up between the area and the perimeter. The perimeter is the distance around the shape, and I'm using addition to add up the side lengths. Not going to forget any of them. So let's start. We know this is a side length of 3. Let's count here. I have 1, 2, 3, 4, 5, 6. Remember, I'm going all the way into the corner. Now I have 1, 2, 3, 4. 1, 2, 3. Going up, 1, 2, 3, 4, 5, 6, 7. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I just have to add up the sides. So 4 plus 3 is 7, and 7 plus 7 is 14. Okay, 6 plus 3 is 9, and then 9 plus 9 is 18. 4 plus 8 is 12. When I add it up, the perimeter is 32 feet. This is table A. Let's look at table B. So this side is 2. I have 1, 2. Going across here, I have 1, 2, 3, 4, 5, 6, 7. Going here, I have 1, 2, 3, 4. Going down, I have 1, 2, 3. Going across here, I have 1, 2, 3, 4. Going down, I have 1, 2. Going across, I have 1, 2, 3, 4, 5, 6, 7. Going up, I have 1, 2, 3, 4, 5, 6, 7. So let's add it up. Let's just make sure I counted that right. 1, 2, 3, 4, 5, 6, 7. So let's add it up. 7, 7, and 7 is 21. Okay, 2 plus 2 is 4. And then 4 3 times is 12. 2 plus 2 is 4, and then I'm adding 8, 12, and then I have another 3. So when I add this up, 1 plus 2 is 3, 3 plus 3 is 6, and 2 plus 1 is 3. So this is 36 feet is the perimeter. So if you want to choose the one with the greatest perimeter, you're going to choose table B. Okay, let's get this to right. There we go. Table B. Okay. So what are our reflections for today? To calculate the area of an irregular shape, we can split the figure into shapes we know, in this case, individual rectangles. Once we know the area of each rectangle, we can add them together to find the total area of the irregular shape. To calculate the perimeter of each irregular shape, we find the distance of each side and add it together. Here are 2 follow-up questions I'm going to ask you to do. David is the groundskeeper at Triangle Park, scale shown below. David needs to cut the grass 4 times a month. How many square feet of grass will he cut all together each month? Notice the shape is a triangle and he's cutting it 4 times a month. The second part, during the winter, the triangular park and adjacent square parking lot are flooded with water and allowed to freeze so that people can go ice skating. What is the area of the ice? So it's the whole shape is now going to be flooded and it's irregular. It has a square plus the triangle. Questions. If you have questions about anything I discussed or have answers to the problems I left you to solve, please email me or Mr. Lengthy your responses or send us a message on Dojo. I will respond to your messages in my challenge for Wednesday. Please remember, you have a group Google Meets meeting with either me or Mr. Lengthy this week. Talk to you guys soon. Have a great day.